All right, so we got the second part of the electric fields homework, which this just doesn't feel like electric fields in the traditional sense, but that's sort of where IB puts this material. Now, first we want to get a couple problems that are just based entirely on this formula here. You've got electric current, and then there's the charge that passes through the wire and the time it takes to do it. And 90% of these problems is taking delta t and timesing it by 60 to get it into seconds. Like right here, 2.5 minutes. And like the challenge in this problem is to take 2.5 and times it by 60. And that's going to give us 120 plus 30, which is 150 seconds. So we want to know how much charge passes through this wire. We're going to literally take here I is delta Q over delta T. We've got 1.6 amps equals delta Q over 150. And so we end up getting here delta Q is equal to whatever 1.6 times 150 is. 240 coulombs. That's quite a bit. All right. And then here, same idea. Let's convert this into seconds. So 3.25 times 60 gives us 195 seconds. Is that right? Yes, it is. All right. So you want to get the current. Let's take delta Q over delta T. That's going to be 842 divided by 195. And that's going to get us about 4.32 amps of current. Great. All right. Now here, this is where the formula looks obnoxious and the words look obnoxious, but the math is almost invariably simple. The only trick I would say is every now and then you'll get a circle and you've got to break out your pi r squared formula. And you know what's beautiful about this? That isn't even happening in this problem. So it's the problem that says current, it's the formula that says current is basically equal to the charge, like the carrier density, times the area, times the speed, times the charge of an electron. So here we're basically going to say, all right, we got 0.67 amps. That's the current. We've got 8.5 times 10 to the 28th charge carriers per unit volume. Our area is 4.9 times 10 to the negative 7th. We don't know V, and we know that Q is the charge of an electron, which is 1.6 times 10 to the negative 19th. And so we can actually go ahead and get V from all those numbers. And when we do that, give me a second. So I'm getting 1.0 times 10 to the negative 4th meters per second for my speed. All right, here. Once again, here now we've got our power formula. Whenever we talk about energy and time, I always want to work with power. And in this case, that's power is I times V. And here we know that power is also work over time. Let's put these two formulas together. 112,000 joules divided by our unknown time is going to equal 0.064 amps times a voltage of 185. And so when we isolate the time, it's going to be a delicious number. So I'm getting 9,459 seconds. And by the way, to convert that to hours, we divide by 3,600. That's going to be about 2.62 hours. So seconds, or about 2.62 hours. Hey, Lulu. So, and that's number 4. And then, let's see, how many more? Ooh, goody. All right, so here, I'd actually like you to try this problem. One small thing I'll tell you is you'll need to use the formula I equals delta Q over delta T to get the current using these two numbers. And then you can use power is I times V, where V is the 2.88 volts you got before. And then here, once again, we've got a current and a voltage, so we'll use the power equals current times the voltage, and then you'll have to times this by the time. And then the power times your time is going to be the energy you use up. And once again, what's just going to make this annoying is you've got to take your 96 hours and convert it into seconds. Just so you know, the shortcut for that is he times it by 3,600, so you end up using a lot. You use up quite a bit of energy, basically. That's kind of it for those. Again, here we got a power current. Power is current times voltage. And then here, once again, convert this into seconds. So this part of the unit, again, the formulas are maybe like that current formula, I equals NAQV. That one looks a little gnarly, but it's straightforward. The rest of this, though, here. Number 9, I'd like us to do together as a class. And then for number 8, again, take 5.5 times 3,600 to get the time, and then times that by the answer to number 7. So those are kind of some hints on how to do those worksheets. If you need a little bit more help, please come see me. I know I worked through this rather quickly. It's because I really want to kind of get you self-sufficient with some of this IB stuff since, you know, we're wrapping up in about 6 weeks.